All right, guys, let's work on number 5. Remember, I told you guys that number 5 is one of the weird ones. It's the acid-base one. But to do this real quick, I want you guys to remember that if I have water, then I'm going to break it apart between H and OH. Remember that water, I mean, you guys already know this, water is neutral. It's neither acid or base. And remember, if I attach H as a cation in front of something, this becomes an acid, right? Like hydrochloric acid, for example. Or if I have OH, then that's going to become a base. So water literally has acid and base put together. That's why it's neutral. Okay? So in this case, I have one of something and I have two of something. So one is trying to replace the other. So most likely then, this is going to be a single replacement. But the more proper name would be the acid-base reaction. Okay? So I have this one trying to replace that one. So let's see what that one will look like if this one replaces that one. So I'm going to have KOH, and then I'm going to have H left over by itself right here. And remember that H cannot be by itself. If it's not an ion, it has to bond with itself. It's a diatomic Brinkelhoff gas. So it's going to be like this, and I already know it's going to be a gas. Now, going back to our flow chart, remember that if I have a group 1, anything group 1 really, it is always soluble. So I have aqueous right here. Okay, so did I have a reaction or not? The answer is yes, because I see solid, liquid, and gas on this side. So remember, I don't have a reaction only if I just end up with aqueous. Okay, so in this case, it's not aqueous, it's aqueous gas. So I'm going to say yes, I had a reaction. So how would I write this in net ionic equation? Going back to our rules from, let's see if I can find it, from one of these things, I told you guys to leave solid, liquid, and gas compounds alone. So let's leave it alone. So I'm just going to bring down the potassium, and I'm going to just bring down the water, just leave it alone. And then I am going to then leave the gas alone, but I am going to break this apart. So I am going to say K is like this, potassium is like that, and then I am going to add the hydroxide like this because this broke apart, okay, because that was aqueous. Now, this is this one, and this is that one, and I got that from that. All right, my next step, I need to make sure they all balance. Remember that if it's not an ion, they have a 0 charge, right? Neutral charge. So on one side of my equation, I have 0 and 0. So right now it's neutral. On this side, however, I have 1 positive, 1 negative, and the gas. And on the other side, I see I have a plus and a minus and a 0 because this is not an ion, neutral. So plus minus, it makes it 0, so 0, 0 on both sides, so I'm good to go, and this is balanced. So this will be my net ionic equation, and then this is a single replacement or acid base.